Guys, you guys did a pretty good job on today's lesson, but I just thought, especially for those that had to miss today, that I would do a quick review. The first several problems ask you to find a composition of a function involving using a number that you're plugging in. So like f of g of 3 or g of f of 2 or something like that. Um, So I thought this would be a good example. If f of x equals 3x plus 1 and g of x equals x squared minus 2x minus 6, which is actually what they use in your book for problems 1 through 8. They also have an h of x. We're not going to use it in this problem, so I didn't type it. So I want you to find f of g of 3. So all you're going to do is you're going to take the number 3, you're going to plug it into the g equation in place of x. You're going to get an answer for that and then plug that answer in for x in function f. So I'm going to start out with g of 3. So I take this g of x equation, everywhere there's an x, I put a 3. 3 squared minus 2 times 3 minus 6, which would be 9 minus 6, which is negative 3. And then I'm going to take negative 3 and plug it into f. So the answer from plugging 3 into g gave me negative 3. Now I'm going to plug negative 3 into f. So 3 times negative 3 plus 1 would be negative 8. And that's your final answer. F of g of, of 3 equals negative 8. You plug 3 into g, get an answer, plug that answer into f, and it gives you your final answer. And that's how you do composition of functions with numbers. Then they want you to move to where you're doing composition of functions with just plugging in expressions in for x. So I'm going to find f of g of x first. F of g of x. And what that means I'm going to do is I'm going to take the g function and I'm going to put it in for x in the f function. So I'm going to take this and I'm going to put it over here everywhere there was an x. So instead of it being 1 minus x over x, it's going to be 1 minus 1 over 1 plus x over 1 over 1 plus x. And I am okay with you leaving it like this for now. We will learn how to simplify rational functions later in college algebra. I believe it's chapter 5. No, chapter 4. Chapter 4, we will get to that. Right now, I just want to know that you know where to put the expression. So you're putting g into f. Now we do need to talk about domain here. X cannot equal negative 1, because if x were to equal a negative 1, I'd be dividing by 0 here, and I'd also be dividing by 0 here. If I ask you, instead of doing g of f of g, if I ask you to do g of f of x, what you would do is take that f function and plug it in to g where x was. So let me erase what I have up here from the last one. So g of f means you're going to plug f into g. So I'm going to take this 1 minus x over x and put it over here where x was. So that becomes 1 over 1 plus 1 minus x over x. And in this case, you can leave it like that again. X cannot equal 0 because then you would be dividing by 0. It also, let's see if there's anything else that it can't be. Alright, so that's the only thing that's going to be x cannot equal 0. I can graph it to make sure. The only other thing I would have to worry about if there was anywhere where this would be negative 1. Because since this is 1 plus this amount can't be negative 1. So what you could do just to make sure is write this equal negative 1 and see if we could find anywhere. If you multiply x on both sides, you get 1 minus x equals negative x. And then if you added x to both sides, you get 1 equals 0. Well, 1's never going to equal 0. So that means there's never going to be a place where this would equal negative 1. So you don't have any limits there. So this is my function, g of f of x, and we're going to leave it like that until we get to chapter 4 where we simplify rational functions. And then x can't equal 0. Good luck with your homework.